Friends, now we will see the topic helical antenna. Now, the helical antenna, we can construct helical antenna by using an conducting wire, and we have to just wound that conducting wire in a circular shape so that we form like an helix, a circular helix. Then that will be like an helical antenna. Now, Now the conductor. So as I told you, we can just make an helical antenna by an conductor wire. So here the helical shape of that particular antenna, right? That will be acting like antenna, right? And one part of that is one end of the antenna uh, can be given to the ground, and the other part will be just connected as can be left as such, so that the radiation can be uh, maintained by the helical antenna. Now, the properties of this helical antenna is such that it provides circular polarization. So, it is very good for the application point of view, right? Uh, so it provides circular polarization, and this circular polarization is due to the fact that the shape of the antenna is in terms of circular, so it provides circular polarization. If that particular helix is like conical, it will provide the conical polarization. So it depends upon the structure how we make the conical helical antenna. If it is like ellipse, then it will be like so it will provide elliptical polarization. Okay. Now the another property is that it is used for the very high frequency range. So very high frequency and even the ultra high frequency ranges. So one application I just tell that it is used in satellite communication. Okay. So right, next, construction of helical antenna. So as I told you that a conducting wire has to be turned around and made in a shape of an helix. Now how now in this construction we could see, so the wire, so here it is not just an ordinary wire we have taken. Here we have taken a coaxial cable. In coaxial cable we have the center uh, conducting wire. So this conducting wire we take, so we just cut the outer conduct, that is outer um, dielectric material, whatever may be present. So we take just the conductor and we wound this particular conductor in an helical manner. So you can see, so here this is the coaxial cable which has been taken, and we have taken from an inner conductor. So the part of the inner conductor, this is like plus, right? This is the negative charges, and the remaining will be like a positive charge. It will be like a dipole construction. And then we can see that means here one thing to be noted, that the inner conductor, the other end, the negative sign which we have represented here, this will be like a ground. Okay. And the inner conductor we are going to wound or according to the axis of the coaxial cable. So we have an axial direction. So this is the axis of coaxial cable, and uh, now we will be after wounding all this. So here a few parameters are there which we have to just remember. Now what are the parameters here is, uh, now we can see that the place where, so we come from the point A to B to A. So in the figure, it is like a feed wire, right? It's a feed wire, right? It is connecting from B to A. So you can see that the point B to A, and that length it has been taken as small l. So it is an initial state, and then right, and then we can see, so one complete round it has been taken as the circumference or the length of the particular single loop of helical antenna, right? So when I'm telling as loop, now here a loop antenna which we have seen in the previous video. Now if we have one particular conductor in a form of loop, and that is a loop. Now if we are having n number of turns for a particular loop, it will be becoming like a helical antenna. So the circumference of one particular loop has been taken as L, right? L, and in some books it will be like circumference C, right? And then we have that is the width of this particular conducting wire has been taken as small d, and the distance between each turn is considered as capital S. Okay. And then the total number of uh, now if you can see here, capital A means the total number of yes, that is the now total number of turns into the distance. So we will be hitting the length of this particular helical antenna, right? Then to the right hand side, completely right hand side, we can see the radiation pattern of helical antenna, where it has major lobe, very good major lobe, and its minor lobes, that is the side lobes we have. So it also has side lobes, right? Then next, coming to this construction where we can able to see the design, actually the design of the helical antenna. So how we have to design is depending upon the value of the total length of the wire, we can design it, and what should be the angle being suspended from the particular point. So this will be the formula. So by using the Pythagoras theorem, we can just have, right, so all the equations here. You can see the angle which we made. Now we can see once that S is the distance between the two loops here, and L is the complete distance between one loop, and what is C here? C, we can see here the C is pi times d. Now this length, right, the perpendicular axial length, or the distance from your one end of the coaxial cable to the other end, right? Whatever we have taken, right? This has been taken as C, this 5 times D, right? So here the major parameters which we have to design as alpha, right? So the amount of turn which we have to make. So alpha is equal to tan inverse of S by pi D. So we know that, right? So how we calculate tan theta equal to opposite by adjacent side. So with that we can just calculate alpha value, right? In here we have the two cases. When alpha is equal to 0, it is as loop antenna. If alpha equal to 90 degrees, it will be like a linear antenna, right? Then next, we have three modes of helical antenna: normal mode, axial mode, and conical mode. Now it depends upon the circumference, that is pi times b. Right? Pi times b, we can see that c equal to pi times d. If c is very much less than lambda, we have that as normal mode. Okay? Right? And then if c is approximately equal to lambda, it is axial mode. And if c is n times lambda, that is greater than lambda, then it will be like conical mode. Now we can see the radiation pattern at the top. Right. So for the normal mode, when c is less than lambda, we just have like a dipole-like structure. The radiation pattern is like a dipole structure. But when c is approximately equal to lambda, it is an axial mode, which is the required. Actually, in helical antenna, we want the axial mode where uh, where it is very important that we want a high directivity, so we use the helical antenna in axial mode so that we can radiate the signal in a desired direction. Right, and the other mode, conical mode, we can see it has the major lobe which is suppressed, and the side lobes are being dominated. Okay. So conical mode is very it is less in use in the application point of view. Next. Now these are the formulas which we have to remember for small dipole and small loop and axial ratio. and for the circular polarization, the axial ratio should be equal to 1. Right? It's important that for the axial ratio equal to 1 for the circular polarization, that is root 2 times of uh, 2 times of s times lambda. Now, this is a formula which these are the formulas which you have to remember for the helical antennas, right? And then for the axial feed, so here the R value, that is the circumference speed, it should be like 150 by square root of c, right? And c lambda, it is the c lambda and the cell circumference in terms of lambda. So it should be between 0.8 and 1.2. The value of your alpha should be from 12 to 14 degrees, and then should be greater than 4. Right? Now all this has been taken from NPTEL videos, and then another thing is the radiation resistance. The radiation resistance we can observe that the radiation resistance is zero point 0.6 ohms, okay, for helical antenna, and the axial ratio for that, the value of AR, it is 21.94 decibels we get. Okay. So it's here one point to remember for an infinite bond plane in books we will be having the wire length as lambda by 4, but in reality it will be greater than lambda by 4. Okay. Then next, now these are the formulas which we have to remember for the helical antenna. That is half power beamwidth equation, then beamwidth between cross Snell's equation and its directivity, right, and the gain. So gain and the antenna gain is approximately 60%. It's very good for the helical antenna. Right? So then now this is the mode which will be used in this axial mode. The value of the electrical field intensity and the phase difference sign. And these are the formulas which we use to calculate the electrical field intensity. Then, coming to the application of helical antenna, helical antenna is more widely used in AM broadcast, and it also used to null down the AC by noise, and it decreases TV street noise harmonics. And in low frequencies also it can be used for RFID applications, then gate parking and airport door controls. So these are the very good applications of helical antenna, which are in the industry and which are being used in commercially. Okay, thank you for listening to this video. Thank you so much.